In this video, we are going to discuss 3D scanning large parts with the Creaform handheld 3D scanners. And basically, we're going to just show you some tips and tricks on how to scan these parts using some of the best practices to make sure you do a good job and try to accurately capture very large parts. And specifically, we're talking about the Creaform handheld series such as the GoSCAN and the HandySCAN series 3D scanners. Now for this example, we are going to be 3D scanning some parts for what is called a cone crusher, which is basically a big rock crushing machine. And the part you see here is about 80 inches in diameter, so it's very large, and we need to scan both the outside and the inside so that we can do some 3D inspection. But you could also be doing reverse engineering. It really doesn't matter. The process will be pretty much the same. So we're going to walk through the process on this specific example. Let's start by taking a look at the CAD file for this part, and we're just going to do some illustrating on it and walk through a few different things. So as we said, this part is about 80 inches in diameter, so it's very large. Now I'm going to assume for a minute this part is sitting on the ground, and first thing we obviously need to do is target it. Even with the if we were using the GoSCAN, which technically doesn't require targets, you would still want to target this part. If the part is magnetic, then go ahead and use magnetic targets. That would be the fastest way to do it. And you're going to need the targets about every 4 inches or so. You can get away with a little bit bigger distance on the GoSCAN, but targeting is targeting. Just space them out and you get the general idea. Now, if we were just reverse engineering this part, you could target up about a third of it, maybe a half of it, and you would only need to scan probably about this much of it, between a third and a half, and that'll give you enough data to find the center axis through the part. And ultimately, if you're just reverse engineering it, you just need to get enough data so that you can get a cross section that fits through the part, assuming you need to do both the inside and the outside, and then you can find that center axis and then just create that sketch and revolve it around. So that's one nice thing about reverse engineering, assuming the part's pretty much the same all the way around, is if you scan a third to a half of it, you've got enough to get a good quality center axis, and then of course you have enough data then to cut a section through. But let's talk about doing inspection. So for inspection, if we're inspecting the whole thing, then of course we're going to need targets everywhere. So I'm not going to draw every target, but you get the general idea, okay? So you would target this thing up and be ready to go. Now, the best way when scanning something large is what we call the spider web method, okay? And what you'll do is you'll start somewhere. Now, since this part is symmetrical, we're going to have to, it's circular, we're going to have to do this multiple times. But you would basically start scanning, let's say right here, meaning aim the scanner, pull the trigger, and we're going to pre-scan the targets, okay? That is the best way to do this. It'll be the fastest too. So you tell the software to scan positioning targets only, and then you start and pull the trigger, let's say right here, and then you work your way out. So you would scan out and come back, 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 etc., etc. And you keep doing that till you get kind of this spider web pattern. Now, obviously, the part is round, so then we need to kind of repeat that. So then, if you come out over here far enough, and then maybe get one more here, and then start here, and then do the same thing again, okay? So by doing this in the scanning target mode only, let's take a few more over here and then start here and basically do the same thing. That is the most accurate way to capture the targets in this method, okay? As opposed to, just using a different color, just starting somewhere and, scanning all the way around like this, or, maybe going up and down or something like that. You should not do it that way in acquiring the targets. You should use that spider web method and go all the way around the part and pre-scan those targets. Now, if you don't know where that is in the software, when you bring up the VX Elements software, you will see this button here, and you can toggle it from scan surface to scan targets. And you're going to want to scan the targets only first. And then when you're done scanning, it's a good idea to save those targets into a file. It's just a text editor file, but we'll explain more in a minute here why you would want to do that. But you want to definitely save that file. So one of the real challenges on this part is acquiring the targets on the outside and then getting around to the inside. Because anytime you go around a 90-degree corner, and really in this case you could argue we're trying to go around a 180-degree corner, and we only have this really thin lip along here. And you do not want to try to scan areas where your targets are not spread out very well. So, if you just tried to put targets along here, even if you tried to stagger them, it's not a lot of area, area this way in the X and Y to really do a good job. It could the target map could very easily get confused and flip. So it becomes a real challenge in this case to get from the outside to the inside. So we'll show you kind of two ways of doing this. The first method, assuming this part is laying on the ground, is to use some geodomes with targets on them. Now, what are these geodomes? Well, this is something we made. We designed the CAD file for it, and then just 3D printed these out, and then put targets on it. We glued the targets on just so they stay on. They don't tend to stick well to the 3D printed material. So you can actually download this file. In the description below is a link to download the file, and there's two versions. There's one for the HandySCAN system, and then there's one for the HandySCAN and the GoSCAN, because those scanners use two different size targets. So the HandySCAN and GoSCAN use a smaller target. So you can download a file that has both in them. You can 3D print them out. We glue magnets in ours, real strong magnets. There's a recess in the bottom of it, and you can stick a magnet in there. And what you're going to want to do is you're going to put those domes up on the top. I would put them all the way around, okay, all the way around the part. And then I might even put some kind of, here on the sides, and then definitely I'll draw over here, have one, here and here. So you're going to have a bunch on the top, and then for sure have them on the inside here. And the advantage of that is, so, here's your scanner. Not a very good example, right? And it's going to be able to see those targets, right? And see these domes. And you're going to kind of work your way around the dome, kind of back and forth, and then try to roll over and see the dome here on the other side. And because that dome can be seen all the way around, it's going to start picking that up, and then hopefully start picking up then the targets on the inside. Okay, it's going to be very difficult without them to try to roll up where the scanner's only seeing this narrow. And you can put targets on this top ledge. Go ahead and throw a few on there. That won't hurt. But you're going to need more than that. You're going to need these domes sitting on the back side, so that as you roll up over, it can start seeing the targets on these domes and start picking them up, and then get to the inside. And then, as we talked about, get down in here and then start doing, let's use a different color, start using that spider web method again once you get to the inside. Okay, and it's very important that you get a good rollover and then work your way around this part and to make sure that the inside and the outside line up well. If this is off at all, by the time you get over here to this side of the part, it's probably not going to be lined up well. So I would put those domes all the way around, and as you're scanning the outside and working your way up, let's draw. So we'd have these domes all the way around. Make sure you get those scanned real well as you're scanning the outside. So make sure all those domes get scanned, and then have them on the inside, and then try to roll up over and then come down in and scan the part. Now another method would be to get the part lifted off the ground, on some heavy duty stands, and then what you would do is not only target the part on the inside and the outside, but then you would target the stands themselves, and then you would target the ground underneath it. And the idea here is, you would do your spider web method to scan the part, move all the way around, get all the way around the part, and then you would basically use the stands to come and scan down the stand and down onto the ground. And then again, you could use the spider web method down here on the ground and work your way all the way down on the ground underneath the part, and then you will come back up the stands and go up on the inside of the part. So this will establish a nice base underneath, nice and spread out, this way in the X and Y under the part, and then again use those stands, assuming there's some legs or something that have enough width to be able to help you out. I would also still use the pucks along the top. That way then you're kind of securing that rollover to the inside from the top all the way around, and then again some method from the bottom coming up onto the inside, and having this big target map down on the ground. So, and again, it makes it easier to scan the inside of it with this thing being lifted up a little bit. And so again, this is for pre-scanning all the targets, starting on the outside, working around to the inside. So these would be the two methods I would try, or a combination of both, to get all of the targets scanned. So one of the main reasons we want to pre-save that target file is because it's a very small file. It just contains the center point of the target and the normal vector of the target. Because trying to scan this entire part in one single session file may be a little difficult, because it may get so large. As you're scanning more and more data, the file is just going to become huge. So the better thing to do is break it up into multiple files and then put them together later. So because we've pre-scanned the whole part, so you see it here with all the targets on it, we can break it up into a few pieces. And what I would probably do is, use a marker or some chalk or some tape, and I would literally draw on the part something to kind of segregate it into 3, 4, 5, 6 pieces. Some of this may depend a little bit on your computer. And then what you're going to do is scan those areas. So let's break it up like this. Now, part this size, I'd probably set my resolution in the VX Element software to something like 2 or 3 millimeters. Now remember, as long as you're saving that session file, you can crank that down later. But something this large, I'm trying to go down to like a 0.5 millimeter, a 1/4 millimeter. You don't really need it, and it's just going to make everything slow down. So when you're doing the scanning, scan at a higher resolution, higher meaning a larger number, 2, 3, 4, 5. That'll make the actual scanning go faster. So as it's rendering and everything, it can go much faster. And then when you go to scan a segment, so you'll load in the target file, and then you'll start scanning. And then let's say, these are the areas you've marked. Let's use a different color. you'll go just a little bit beyond that and scan this whole area like that. You just need a little bit of overlap, not much, because you're going to use the targets to do all the alignment. Okay, so you don't have to worry about that. So just scan this whole area like that, and get it all scanned good, and then you will I would do both. I would then save that session file, and then I would just, as kind of a backup, save the STL file. Okay, and so you'll do it for that one, and then start a new one, do it for this one, and again scan the whole area and just work your way around. Okay, let's just do the outside. You would do the same thing from the inside as well. I would still break it up. Okay, but definitely do this in pieces with slight overlap. Next, let's talk about some of the settings in the software when you're going to do the scanning, or really when you're going to do the processing. Now, the settings are a little different depending on the scanner. Starting with the HandySCAN 700, let's look at the scan parameters here. So again, I would crank the resolution up higher, but we'll just leave that for now. You can go ahead and fill the positioning targets, and you can optimize the accuracy of the boundaries. Now, if you're doing inspection, you're going to set things differently than if you're doing reverse engineering. So, for example, you want to keep a lot of these commands turned off, or basically the sliders all the way down. So, for example, optimize the scan mesh, you keep that off. Decimate doesn't matter. You can decimate if you want. Just be careful you don't go too high. I would not autofill holes. I would not bother removing isolated patches. You can always, clean that up later if you need. And definitely do not optimize the scan surface, because most of these commands are going to alter the scan data or change it. And if you're doing inspection, you don't want to be doing any of that stuff if you can help it. So keep most of these things turned off. Definitely don't optimize the scan surface. Optimize accuracy of boundaries is fine. You could leave that one on, and then that's it. So go ahead and then just hit apply in this case for the HandySCAN 700. Okay, for the HandySCAN Black, it works a little differently. You have the finalized scan parameters. I would definitely turn on the optimize volume accuracy. That's going to go and look at the targets and try to optimize them to make sure it's accurate. You can go ahead and fill in the positioning targets, and you can optimize the accuracy of the boundaries. What I wouldn't do is I wouldn't smooth boundaries, I wouldn't reduce noise, I wouldn't sharpen edges. Decimate's up to you on the HandySCAN Black. It's an auto. You don't have a lot of control over it. And then there's the autofill holes. I wouldn't bother filling holes. It just takes longer. Same with removing isolated patches. You can delete those pretty easily. And again, set your resolution up typically higher. But these are the settings I would use for the HandySCAN Black. Okay, and for the GoSCAN Spark, I would, optimize volume accuracy, optimize surface. I would definitely turn off. You can fill targets. You can optimize the boundaries. But again, turn off smooth boundaries, reduce noise, sharpen edges. Auto decimate's up to you. And fill holes. Turn all of those. All of these should be turned off. Now over here, the positioning method. If you can get away with targets only, that's going to be the most accurate way to scan. So if you've pre-scanned all the targets and you've put enough targets on the part, then go ahead and do that. If you start using geometry or geometry and texture along with targets, theoretically you can introduce some inaccuracies because it's going to try to align to geometry, and that's just not as accurate. So if you can use targets only, that's going to give you the best settings along with these over here for the GoSCAN Spark. All right, so we mentioned earlier about scanning the part in sections, and let's just take a look at what that would look like. So what you're going to want to do then is import all your scan data either in the reverse engineering or inspection software that you're going to be using. And because you're using that target file every time you start scanning a new section, when you import all the scan data, it should all come in aligned. And what you don't want to do is do any additional aligning of that data. You want to just bring it in, and if you want, you can merge the multiple scan data sets together. But you do not want to do any kind of best fitting or aligning or moving the data, because it should be very well aligned, and you should have just a little bit of overlap, and just merge the data together if you like, and then use it for your reverse engineering or your inspection. Another great advantage of using the magnetic targets is, here's a trick we use to remove them. We have a small little shop vac, and we only use it for this process, so there's no other dirt or junk in the vacuum. And we literally just vacuum off those magnetic targets, so it makes it super fast. And then we just empty them out of the vacuum and we reuse them. So if you can get away with vacuum or magnetic targets, this is a great way to basically collect them off of the part you've scanned. Okay, so just to wrap up 3D scanning large objects, we'll run through everything we've discussed, starting with pre-scanning all of the targets. That is the fastest way to do it, and it's the most accurate way, by pre-scanning all those targets. Save that into a target file when you're done scanning the targets. Use the spider web method when acquiring all of those targets, basically moving from the center out, back to the center, and then out in another direction. To get around sharp corners, use something like those Geodomes. And again, there's a link below. You can download an STL file, 3D print those out yourself, and apply the targets to them and put magnets on them if you want. And then perform multiple scans. If you try to scan something very large in one file, the session file becomes very large, and it's hard to work with, and it possibly can get contaminated. So your best bet is to load in that target file, scan an area you've got marked off with a little bit of overlap, save out that session and that STL file, and then do a new session, import that target file back in, and do the next section. If you can lift the part off the ground, like our example, and scan the ground underneath, that's just going to help, not only getting inside the part, but just giving you more targets in that XY plane. It really is going to kind of depend on your part a little bit. Certainly use the magnetic targets if possible. They're just faster to put on, and you can use that vacuum to take them off. In the VX Element software, do not massage the data. Some of those settings we talked about. This would really be for inspection. If you're doing reverse engineering, that's really up to you. But when you start optimizing the surface and things like that, you are going to change the scan data. So just be aware of that. And definitely optimize the target volume for the HandySCAN Black and the GoSCAN Spark. That'll actually help keep the accuracy high. Set your mesh resolution to at least 2 millimeters. This will be dictated a little bit by the detail of your part. But if your part is pretty kind of smooth shape, you could go higher than that. If you do a good job scanning, you can always turn that resolution back down in the session file. And then we didn't really talk about this, but there's also the Creaform MaxShot photogrammetry system. This would be something you set up and do ahead of time, and we have videos that go into a lot of detail on this. But that will get you better accuracy over a long distance. Basically a large part, you're going to get increased accuracy over distance. So that may be something, if you're doing a lot of large parts with the GoSCAN or the HandySCANs, the MaxShot might be a good option. And finally, you can use multiple scanners. As you see here in this video, this is another video we created where we actually use 3 scanners at one time on a large part. So that would be another option you have, is to use multiple Creaform 3D scanners.